Welcome, everybody. Tonight we're going to be going through Unit 2. I am recording this outside of class time for publishing, hopefully, during class time. And you will watch this video basically to replace the class session. This is a lecture on the Unit 2 topics, and then kind of a little bit of a primer on the homework. All right, let's get started. I'm going to pull up the PowerPoint here. And I will go into this mode. I'm not going to go into full-on PowerPoint presentation mode, so I can switch between screens easily. But basically, these are the key takeaways from last week. We learned a little bit about what NLP means, and we just got our feet underneath us, basically, to kind of get like the terminology in place. Tonight's agenda is basically to look at like where the data comes from that drives NLP, where we store it, and whether it's structured or not, and how we can work with different data formats aside from some of the ones that we've been looking at. All right, let's go ahead and move on to this slide here. And so the question asked is, why is data so crucial to doing this stuff? Well, as you guys have learned, all of AI really is driven by data. We can't really develop artificial intelligence on any level without not only information, but ample amounts of good quality information. It's important to every aspect of AI, which is why we teach AI with the data analytics program. They're tightly intertwined, right? You can't do data analytics without data, and you certainly can't do artificial intelligence without data, because then you cannot train your models to do anything. All right, so here we kind of like reinforce that thought, and I will mention that this slide here, when I had the original version of this, there was a duplicate of it, so you probably are seeing two of these slides in your slideshow, and I apologize for that. But when we started like building machine learning in principle, all of that machine learning stuff, if you remember, like if we don't have data and if we don't have really large data sets, how do we train the models, right? And in fact, we would reserve a portion of the data for training, like a large chunk of it, and then we'd have to also reserve some for testing, right? And then hopefully after all that training and testing, we can take fresh data, throw it at the model, and it evaluates correctly. That, if you guys remember that whole thing, but all of it relies on data, and the more data you have, the better your models are trained, generally speaking. So think about it like this. Why do we need it? It says machine learning algorithms have nothing to learn from without a proper data set. So if we have no data, how does it do a failed attempt, or how does it have a successful attempt, and how does it tell the difference between them, right? And they have the data set here up on the screen that comes from that iris data set, and I don't know if you guys remember looking at that. That's a very classic one in data science that people look at. But how do we know if your model is good or not if we don't have real data to look at, right? That's just the bottom line of it. And this is kind of an interesting little thing here. It says, continuing on the why do we need data thing. And I find this a really fascinating slide because, with natural language processing, it says computers are better at understanding speech and text these days, right? And I know you guys experience this, where you like turn on, like, let's say the voice assistant on your phone, or you turn on Siri or Cortana on your computer, and they're pretty good at listening to your voice and getting it correct. In fact, even like this video that I'm recording now, when I like push this to YouTube and they like close caption it automatically, same thing's happening there. It's listening to my voice and it's converting it to text, and it's doing it with a really accurate model. And in fact, it blows me away that it gets like acronyms and really weird sounding words correct. It even gets my ums and ahs and types those in. So I try not to do those, but we all have that little quirk. So what I like to compare, at least with this piece of information, is voice recognition has been around a very long time. actually. I think a lot of people are not aware of that. In fact, it delves, I think, way back into the 70s and 80s when they first started working on it. But by like the early 90s, when I was first working in IT, we started to get people within our organization that were starting to use tools like drag and dictate, which would require that you would train the voice recognition software on what your voice sounds like. So what they would do is they would give you these passages to read, and then you'd read it and then go like, oh, that's how you say integration. All right, got it. And then you would do it a bunch of times. And if there were certain words that still didn't get, it would throw them back at you. But before you could use the voice recognition, you would have to train your software. Right. And in the early days of smartphones, I remember doing that too, like where you, okay, let's read this passage. Okay, I think we're good. And I don't know if you guys have noticed now, when you get a new device, you just turn on the voice thing and it just recognizes you. You don't have to train anything, right? They've like figured all that stuff out, which is, it blows my mind, right? But that's what the slide is about. But basically, it has gotten more accurate, especially lately. Right. And in fact, in the last 5 to 10 years, it's gotten remarkably accurate. So very, very cool. The stuff has totally evolved. So now the question is, okay, so you need data. Like, how much data do you need? Well, what do you got? It's basically my answer. The more data, the better is really kind of the general rule of thumb. So like, how did those voice recognition things get so good? The reason they got so good is because initially they had, weird geeks like me training their models, right? And they would probably backfeed that data somehow. But, after decades of doing that, and tons of data being fed in, they now have this super robust data set where they can kind of accommodate like people's weird accents, regional differences, male, female, child, adult, et cetera, right? And to the point where it works around all those issues. So there are some general rule of thumbs, right? When you're processing data and you're trying to build a model to have it recognize things. And this is a general rule of thumb for all of AI, by the way. So at a bare minimum here, it says get around 1,000 examples of the data set, basically. And it says for most average problems, really, you should have a data set that maybe has 10,000 to 100,000 examples to train it really well. And then for really hard problems that are much more difficult, it says here you should start with 100,000 samples or examples and then go up to 1 million. So once again, the more, the better in terms of, doing this. All right. So like, where do you get the data? Oh, okay. So we already are familiar with some data sources, but in some cases, you do have to acquire the data in different ways, right? And we're going to go kind of through that. And the first thing that they kind of point out here is interviews and surveys. So like, for example, I could just sit down with a human being like you or me or whatever, and I can just say, hey, do you like green or blue? That type of thing. Or how do you say potato? Or do you say potato? Or, whatever. So just by direct human interaction is one way. So I can collect data directly from people. And in the old days, we would survey people, right? And yeah, we would just do it with pencil and paper. Maybe you'd hand them the pencil and paper, or you ask them a question and you write it down, right? But you manually can collect the data, right? And that's still used, absolutely, right? What has happened since though, right? Like we all exist on the internet these days. We're visiting websites all the time on our phones. We're doing it on our computer screens. We're searching stuff or social media, whatever, right? Like you hit a gazillion different websites every day. And the screens that you see contain information, right? And there's a lot of information on websites and it's structured in weird ways. And here's kind of an example of some data that was scraped from a website. And really this, and we'll learn about this in a little bit. This is an example of JSON data, right? That's scraped from a website. But if you looked at like the source code of any website, by the way, and just real quickly here, I'll bring up my my browser. You can right click any web page anywhere on a blank spot and look at the source code. And here's more data, right? Well, actually, this is the code that makes the page, but intertwined with that code is also the information that's sitting on the page. So I can grab that data too, right? So we'll talk about that in a little bit. That has a special name to it. But just because it's on a website doesn't mean that you can just like copy paste it, right? Well, kind of you sort of can, right? So like when you are working with websites, they have a process that you can do to extract the information, right? So we just saw, like, for example, there's code behind the page that contains like I guess the structure of the web page, but also contains the information. And there's this thing that we call scraping, right? Which is to visit a website with a piece of software. The software scrapes the content off the page, then runs it through an algorithm where it throws away the stuff it really doesn't need, like, for example, ads or styles or something like that, and then finds the stuff that's actually content, like the Green Bay Packers score or something like that, and converts it into a data file. And this is a really, really common practice, right? One of the more popular languages for doing web scraping, by the way, is Python. And if you want to Google that, you can even ask a Gen AI, like, how do I scrape data from a website? And you can even get algorithms for it. Of course, it's not just plug and play. There's a little bit of tweaking that you have to do to make it work to get the right data. But it is a thing that people do, right? So a lot of websites will scrape other people's websites to get information, grab the key information, and then republish it. And how do you like that? So whoever created the content originally, is kind of like not getting their fair share of like the profits or whatever, if it's intellectual property. So that's kind of a thing too, right? So like whenever you publish stuff on the internet, copyright it and say can't use without permission, and if you grab it, we can come after you with our lawyers, that kind of thing. But there's also people that don't care, right? Like, so some guy might have a Green Bay Packers fan page and post all sorts of stats about the Packers. And if you grab content from there, well, okay, well, he's not copywriting it. You can grab it. All right. But this is a thing people do. It happens a lot more than you might think. But the process of extracting information from a web page is called scraping, right? And you can do that with Python. Now, what a lot of people do, though, is, they need quality information, to do their builds of whatever they're building. And there are places where you can pay for your data sets, and they have a couple different links here. So for example, like if I wanted to access a medical database, where they have like like the results of like patient tests and medications and things like that, like real valid scientific data gathered by real valid professionals, right? Well, you can access that information often, but the people that hold the data will probably charge you money for it, right? So it's not free, right? The other example, the screen on the left here, you notice the New York Times developers sign-in page. So like if I wanted to extract data from the New York Times, they probably don't take kindly to you scraping their articles, but they'll give you access to whatever data they've collected. Like they do statistics, they do charts and graphs, like where is that data? Well, it's accessible to developers, but once again, you got to pay for it, right? But if you really want that quality data, and we assume their data is quality, you must pay, right? So that is a thing, right? And people do pay big money for information. And this is why I often tell people that the new gold rush of the 21st century is information, right? The information we generate and who holds it has value, and people pay money for it. It's a thing, right? There are also public data sets. So there are organizations that take information that's out on the internet and then compile it or generate it from scratch over long periods of time, and then share that data publicly, right? With the principle of like everybody needs to know, right? Like this is the internet, it's free and open access to information, but somebody's got to put it together to share it. All right, so here's a really bizarre example. At Stanford University, they put together this data set, and this is one of these data sets that is kind of foundational. And I want you to think about this for search engines, in the form of searches that are in the form of questions like, what does, I don't know, acquisition mean, for example. And you just get like a response to a normal question. But it's also built on these public facing data sets, for example, like on top of Wikipedia articles. And that's what they're pointing out here. So like people put information into Wikipedia. Okay, granted, Wikipedia can have its issues, but generally the information in there is pretty good, right? And accurate. So like somebody asks like, what is the formula for the volume of a cylinder, right? There's probably a Wikipedia page about calculating it. And therefore they have like a question that normal people might ask associated with a spot on the internet like Wikipedia where you can directly get the answer. And they put this into a data set with all these pre-configured questions. So I'm actually going to visit the site here. So I'm bringing that up on the screen. And they talk about like what this is and what it is, and that this is a data set that they've been working on. And apparently they have a previous version and now it's a new version, which is 2.0, where they have, it looks like Squad 2.0 combines 100,000 questions with over 50,000 unanswerable questions. So what they're trying to do here is there are some questions that are answerable and known, like the one I just said, like what's the volume of a cylinder, what's the formula or whatever. And then there might be questions for like what do I feel like having for dinner tonight? Well, that's kind of unanswerable, if you see where I'm going with that. So some questions can be answered and they form a data set, but they also have questions that kind of can't be answered in their data set too. And I think it's really a fascinating thing that somebody's gone to the trouble of doing this. But this type of information does become the basis for a lot of our search engine results, and what our Gen AI engines are doing. Like, why is it you can ask it a question, it can come back with a response so quick? Because it's already got it built in. There's people that have answered those questions already, and they've put them in a database or data set that can easily be read by the language model, and now has become part of the language model, if you guys can kind of fathom all that, right? So kind of interesting that people go through that process. How does that happen? It's not automatic. It's been worked on for a really long time, right? So that's one of the ways that we get data is through data sets like the Stanford one. And feel free to explore that one. It's pretty bizarre and interesting. Here's another one. And a lot of people don't know this, and Amazon's had issues with this actually, but like anytime you go into a product on Amazon, they contain like any product listing you pull up will have like the information about the product and the price and where you can buy it and the shipping costs and related products and yada yada. And then if you scroll down the page, one of the reasons we like shopping on Amazon is there's reviews. Now, some of us are tuned into the fact that some of the reviews on Amazon are actually bogus, like machines have generated them, whatever. So, but still, when you get real ones, right, and ones that are ranked high, you can read them and you can see, okay, well, this person gave it 5 stars, and okay, that's kind of what I'm doing. Okay, that's great. I think I'll buy that, right? Or if you're like me, I look at the 1-star reviews to see what the complaints are. Like, hey, this thing is broken, I can't get it to work, or whatever it is, right? But it's valuable, right? So what a lot of people don't know is Amazon, ever since they launched as a website, has kept all the reviews and put it into data set that you can access and look at. So if you want to see if something's good, you don't have to even go to Amazon to do it. You can just go right to their data set. And I want you to notice here, this was ported. So this is actually on a school server. I'm not University of California, I don't know, University of California, San Diego, I think, whatever. This is on one of their servers, but they show you all the Amazon product reviews and they show you the data format as an example. And then you can download the reviews for various segments of time. They also have question and answer data, kind of similar to Stanford's, all built around the Amazon platform and their products. And it goes on and on and on, and they have a bunch of other stuff from other places too. But these are data sets that are out there that you can just access, right? And because they're off of these big company sites, they're at these educational places, and the educational places are just sharing it because, hey, they're just being cool and smart, right? Here you go, folks. Big data sets that are very, very useful. All right, moving on. Here's one that we've already played with, right? If you guys remember in the previous course, the Intro to Machine Learning course, we had an assignment where we worked with some of the IMDb movie reviews and descriptions and stuff like that. And I don't need to go to this one. You guys have seen this one already. But that data set's out there too, right? And so feel free to access. Wikipedia has the Wikipedia question answer corpus, and which is basically, once again, a combination of question answer pairs, right? So like, hey, what's the Python code for outputting a statement to the screen, right? And it'll find it on Wikipedia and give you the answer, and that's probably one that's out there, right? And look where they built it from. They compiled it from Bing query logs or searches on the Bing platform. There's over 3,000 questions and 29,000 answer sentences, and then with just under 1,500 labeled as answer sentences. But this is something that is building, right? And other people are also doing work on top of their work already, like Stanford, right? So you see there's using the same data set to generate different question answer results. So if you don't find it in one Q&A corpus, you might find it in another Q&A corpus is kind of the point. That's kind of an interesting word too, corpus, or that's the plural, but also the singular form is data corpora, right? And these are fancy Latin words. It just basically means the type of data that you're working with in a structure. Another one that's kind of interesting. I didn't find a valid link to this. I guess it's maybe down here, but the people that do the Jeopardy TV show over time, you have to imagine that they keep track of their questions and answers, or answers and questions actually is how they do it. And they have over 200,000 questions from their show in a database. And I don't know if I can get to it from here. I didn't actually try this earlier. I guess I'm looking for that magic. Yeah, I'm not sure that I'm finding it. Okay. Anyhow, that I think that's kind of superfluous. But the people that run that show somewhere have a database of that, and they keep track of it, right? And I think that's pretty fascinating. So that's probably a pretty valuable data set, right? Because somebody did all this work of making it a question and an answer. How valuable would that be for a search engine? Huge, right? Because then they don't have to code it. It's already all typed up. That's kind of the thought here. Now, interestingly, the group activity that we see here, this has actually become our homework assignment, right? So your homework assignment basically will be to visit the 3 data sets. I do provide a link for this one in the unit folder, by the way. And then you go through the process of basically looking at the data, looking at its format and why it might be valuable. So that's in essence our assignment for the week, folks. All right. It says, now that we've explored the importance of data acquisition, let's see how data acquisition plays a vital role, and specifically in the development of making large language models, right? So because it is important. So let's read through this, because this stuff is pretty important. It says robust and diverse training data is the backbone of successful LLM. So more data, better large language model, right? The better and bigger the data set, it makes them understand better, and therefore can generate human-like text and response better, because it has so much to refer to. It's important data acquisition in training large language models. It shapes their performance, accuracy, and ability to generalize, right? So like if you ask a human a question and they're kind of hemming and hawing in their head about what the right answer is, well, you know what, that generalization, it's like it could be this or it could be that. Do you ever ask an AI a question and you can get an answer like that? Well, it could mean this, but it also could mean this. It depends on if you're talking about healthcare or IT, right? Like you ask it about an acronym, for example. It says also the quality of the training data is equally as important as the quantity. So having a lot of data is good, but a lot of data that's not good is not helpful. Less data that's better quality is more important. but really you want both. You want a lot of data and you want high quality data. That's why some people end up paying for their data, or they go to other people that have already done the work of gathering the data. And that's why the information has value, right? It has value because it saves others from spending the time to gather it and analyze it and organize it and structure it, right? So you see, yeah, that's very important. All right. There's some ethical considerations here too, right? We've talked about this in AI, that when AI builds on top of data sets that contain biased information, it will also propagate that bias into the AI, which we don't want, right? We also want to protect privacy and use these tools responsibly. So that we don't want like our data to bias segments of the population unfairly, right? Just because of the data set that was fed into it, right? That data set's no good, apparently. All right. So it says various sources such as public data sets, we looked at those, and user generated content offer opportunities for data acquisition for LLMs. So, for example, I just recently got a form from the US Census Bureau in my mailbox, right? Because they're already starting to gather data for the 2030 census. And if I log into their website and provide the information that they're asking, I'm the user generating the content for them, right? So they don't have to like figure it out from a different source. They probably could figure out all of it from a different source, really, but they're asking me as a user to directly generate the information. Here it says data annotation, right? Information basically about the information, and labeling are crucial steps to provide meaningful context during the whole training process. The data annotation piece often in the data world, we sometimes call this metadata. So it's the data about the information. It's kind of like if you're looking at a column in a database, you're like, what's this column for? And there's a little explanation that says, oh, this column is for storing blank, you know, and that information is an annotation or once again, metadata about the information. All right, so if you comprehensively acquire data, so you get like, you know what, I don't want part of Wikipedia, I want all of Wikipedia, right? So the more data, you know, and the more comprehensive and complete that information is, gives that large language model the deeper ability to handle complex situations. Like, and it says here, complex linguistic phenomenon such as idioms and metaphors and sarcasm, you know, and dad jokes, you know, that kind of thing, right? Like, if you don't have context, like, how do you get a joke, right? You don't. And how do you understand sarcasm in those contexts? So that's like one of those things, unless you have a complete data set so you understand what those things even mean, or examples of them, it's really hard for it to understand. So larger, more complete data helps with that. All right, so now let's start looking at what happens, because there's challenges here to get data and then get them into the models so that it's appropriate. So let's look at what some of these are. Okay, we have already mentioned this, but the large language models really need large amounts, so lots and lots and lots of data, and super high quality data. You know, otherwise, if we don't have that, it's not going to train as efficiently. The large language models, it says here, are trained on huge, diverse textual data sets that may include many themes and domains, making them good at many generic tasks, but not necessarily exceptional at any given domain. So in other words, it might give you a lot of great general information. When you get down to the nitty gritty of like getting in there, it might not be able to do that as well, right? That is improving though, consistently. They're not necessarily adaptable or fine-tunable to new areas or jobs that demand specific knowledge or ability. So if like a new thing comes out that they don't really know about, and there's not a lot of information published about it, it's not that it's not a thing, it hasn't learned it yet, right? And think about the world we live in. There's new stuff happening all the time. So the large language models, like human beings, like in IT, right? Like in IT, we always have to learn new things too, because if you don't, you fall behind. The large language models are in that too. But if they haven't learned the new thing, well, they can't answer on it, can they? Right. So if I make a new programming language and I don't really share it with the world and I don't say anything about it, but it's the language, you can ask it questions and it won't be able to answer. So the models only know concepts and facts from the data, right? So when it gets into specific use case scenarios, it might miss certain things. And what they're talking about here specifically is in commercial use cases. So for example, if you're using the large language model to help you with, I don't know, setting up documents for Gateway Technical College, if it doesn't have all the information from Gateway, right, because it only has public information, it might not do Gateway's work correctly. Is right. But if it had access to Gateway's policies and procedures, it might, right? So a lot of times Gen AIs and large language models that use public facing data miss the data inside of a corporation or organization that would give it the specifics it needs to actually operate correctly. The high quality data, like if you wanted to get the data from Gateway, they might not be so willing to share it. Maybe they would, maybe they wouldn't. So sometimes you have to pay for it. And that is a process, right? Because you got to talk to people and they got to approve it. And then you probably have to do a contract and then you got to pay some money and then, you know, et cetera, et cetera. The training for LLMs, because they deal with such huge volumes of data, costs a lot of money. And a lot of that is because it's done out on cloud platforms. And those cloud platforms, especially when you're actively running tasks on them that use a lot of computing power, cost a lot of money. Unfortunately, it's just how it is. And most people don't have the computing resources, you know, in their local environment to be able to do these things. Some do, some don't. So what most people do is they work in the cloud. All right. Now it says, now that we've looked at acquiring data, let's explore the various sources that can be utilized when training large language models. So this gets pretty interesting here. All right. So some of the stuff we've already kind of talked about, but and some of these are common sense. And as you look at this collection here, this is generally stuff that is mostly publicly available and public facing. Okay, so very common. You crawl a web page, extract information, right? Somebody writes a newspaper article. It says, you know, Donald Trump did this, and this is what the job numbers are, and this is our inflation rate, and this is the cost of gasoline, you know, that type of thing. Scrape it from the web page, and there it is, right? Conversational text, social media, right? Like people make their stuff public so people can scrape that, you know. When we have instruction data sets, so like, I don't know, think of like all the stuff on Kaggle, or think of the stuff that I might share with you and make public. There's also the news articles, like we said, so you can scrape those and extract those directly. And then there's those books and scientific papers that are publicly published, and even those that are behind paywalls, but those are considered good, solid pieces or data sources for training LLMs. All right. What's kind of interesting about this, and it says here, the advantages of using custom training data for building LLMs. So in other words, if I use public information to train an AI to do gateway work, it might not have all the info it needs. But if I could get it that private information, right? So in other words, customized training data that, let's say, okay, you can look at our policy manual for Gateway and you can see how we do it. And here's the advantage of that. Well, it's specific to us. So it knows what we're doing and can give you an answer specific to what we're doing within our own context, which is correct for our organization, right? So that makes it perform better. It's more correct. The data is not shared with the outside world. It's more private. And it understands the data better because of the relative context. So, and this, you hear this in ads all the time too, when people talk about AI, is that, you know, when an AI is trained on internal information that like the general public doesn't know, it can give you better responses, right? Like, so if you like ask your Gen AI engine for relationship advice, it would probably do better if it could listen into your relationship, and you gave it data that the world doesn't know about you, right? It can give you better advice for sure. Okay, so there are some ethical concerns here. Obviously, we talk about this a lot. It says the lack of diversity in training data can lead to biases, right? And it perpetuates prejudice and ethical concerns big time. Right. Reliability. Limited data set diversity can result in LLMs returning a false or outdated information, raising ethical issues once again, right? So if you're looking at an old data set and then you ask it a question, well, it's going to give you old data. It has nothing to do with today, right? That's 10 years ago. Not valid. And there's also a lack of transparency. So like what happens is when a LLM can't get to good quality information and it has to generalize based on more basic information, it might give you responses that aren't right because it doesn't really get the full picture, right? We talked about this before. So don't necessarily take it as fact, right? And we've also heard about, Gen AI engines hallucinating and stuff for sure. Insufficient representation of diverse communities and training data can cause ethical harm and biases in LLM outputs for sure. And it says annotation errors or the metadata errors in domain-specific training data can impact the accuracy, also requiring ethical consideration. So in other words, if I have a column in my database and I label it, salary earned, right? But then it happens to be your age, that metadata is wrong, right? So that can blow up a model too, right? So good data, better results. All right, we've looked at a bunch of different data sources, how to work with all that, and the ones that you can get out there publicly for free and that you have to pay for some. But whenever you're dealing with large data sets and data sources, you got to have somewhere to put this data, and we need to store it basically. It says here, as your data begins to expand, you'll need a storage system to accommodate it, right? And you guys face this issue when working even on a laptop or a desktop computer, right? And it's a concern. You go out and you buy a computer, and what I always recommend to people is you buy a computer that has more horsepower than you need, more RAM than you think you need, a better video card than you think you need, and more importantly, maybe than all those, is how much storage you have. Like you take a computer off the shelf and it's got maybe a 500 gig hard drive, and you come to school and your teacher says you need a terabyte hard drive because you're going to fill that thing up in like 2 weeks. So having a hard drive that's of adequate size, and what a lot of us do, and for myself, for example, is I have lots of external drives too that I back up stuff to and store stuff on, and it might not always be connected to my machine, but I can bring those things in, right? But having a place to put your files, right? If you're running a website or an application or gathering information and it's doing that all the time, like you run a website and it's always gathering information, where does that data go? You got to have a place to store it. And it says here, the system should be able to handle all the user-generated data, unstructured training data, such as documents, text files, and so on. And what you start to realize here is when you work with really large data sets, and we've tinkered with a couple, right? In the last course, where it got to be really like almost a gig in size or something crazy like that. You got to have a system that can handle it, right? So that becomes kind of an issue. So we start to look really at what data looks like, because data comes in basically two distinct formats. One would be structured data, and what they say here, like what you would find in a database, right? It's organized. There's data types, there's rows and columns. It's consistent, right? It's reliable, right? Then you have unstructured data, and what they have here is examples, like, and it says here what you find in the wild, like, randomly in the internet or electronically. And that can be like words, that can be images, audio, video, and think of how much content you consume like that. I mean, that's like a lot of what you consume is unstructured, right? Especially like on like a social media site, right? You don't know if somebody's throwing words at you or video at you or a link at you or whatever, right? And there it is. And it's not really in a format, So that is what we call unstructured data. Okay, well, so defining, right? Structured data is clearly defined and searchable types of data. Like this column has text, this column has numbers, this column has dates, that type of thing. It's easy to search and analyze because it's organized already, right? It has a structure to it, so it's very easy to deal with it. It says data resides in a fixed field within a file or a record or a table, right? And usually rows and columns. And then, like if you guys have had a database class, there's a relational database where we have, like a database can have multiple tables of information inside the same database, and they're all kind of linked together with key pieces of information, right? Continuing on here, it says a data set for an NLP task, such as classification, usually requires two things for each training example: text, right? Some words, a single token, a sentence, a document, right? Which is to be annotated and optionally pre-processed, cleaned up basically before it goes in. And then that information to become structured would be labeled, right? So for example, if I sent an email, right? An email has different components. It has like a from and a to, like email address, a subject line, maybe there's a CC and a BCC, and then there's the body of the message that has text in it. But if I, for example, say emails from Ty, right, that's kind of a label, and then the text of those emails becomes the data, right? So it's structured, right? So I have emails from Ty, here's the text of those emails and maybe the date of those emails, but there's a format to it, right? The text itself might be unstructured, but the email is structured, if you see the difference. So they also kind of give you an example of structured data storage, and this is like takes us to the tabular format, like what we see like an Excel spreadsheet or a database table, right? And so we say tabular information, meaning in a table, right? Usually the first row is the labels for each of the columns, kind of tells you what data is there. And then from there on in, it's the actual information. Some fields have information, some don't, but whatever. Rows and columns. Anything that's in a tabular format can easily be converted to a CSV file. We've worked with these a bunch, right? It's kind of like an Excel spreadsheet without the formatting. It just has the data. We call these comma separated value files because if you were to look at it in a text editor, each piece of information, like for example, it would say first name, comma, middle name, comma, last name, comma, right, for the first row, and that's the header row. And then you get into the data and say Bob, comma, blank, comma, Smith, comma, right, and everything is comma separated each row. But it's basically still a table of information, and that's why Excel can read it in and drop it in and put it into rows and columns. But that's tabular data. There's a structure. They make the point here, CSV is easy to learn, right? We teach you that in the program quite a bit. It's easy to parse. Parse means to read through it because it's in rows and columns. I can look at the first name column and go, oh, these are first names. Oh, these are last names. Got it. It's easy to serialize. Serializing it, by the way, is where you take the information and you just send it out in a stream. So all the little bits of information is just, well, here's a row, the word, comma, word, comma, word, comma. Here's the next row, right? And a serial means to send the information in the stream, which means we can send it over the internet or put it in a file. Python, as you guys already know, because we've done it a bunch, works really well with Python. And in fact, the truth be told, CSV works really well with just about any programming language. Most of them, heck, I'll even say all of them usually have tools or libraries that handle CSV files and import them and work with them. Because remember, CSV file is really just a plain text file, right? So programming languages do really well with those, right? Because that's what they speak is text generally. In Python, we have like libraries like the pandas library that allows us to read in the files, reorganize them, extract information, et cetera, et cetera. And we've done that a bit, right? But just to kind of refresh that. All right. So here's an example of a CSV file. And this is a data set that you can go to. This is fascinating that it's even out there. But they have the data set for the passengers that were on the Titanic. How cool is that, right? Like if you're into that stuff, like their name, gender, socioeconomic class, like stuff we kind of don't care about now, I guess. Um, and like you can see some of the information. So age, sex, I'm not sure what SP is, sibling, whatever, the ticket number, how much money they paid, which cabin they're in, et cetera, et cetera. And this is a really interesting data set. But when we read that file, right, if we look at the native file, it'll come up, and I did not do this before. I just want to see if it loads. Okay, so here it is, right? So here it is in the tabular format, which is the preview, but this is the raw format. So this is really what the data looks like in the text file, and it's all text, right? You can see, but when you put it into a table, well, now it looks all fancy, but in truth, this is what it is, right? In its raw format. So that's really the example there. And, very, very powerful format, great way to share information. It works with every programming language. All spreadsheet programs open it, yada, yada, yada. And it's plain text, so easy to transmit. It says here CSV is good in most cases. It's really a great format, and works really well for most projects. It really does, even super large scale ones. It says, but what if you have enormous amounts of data to process, say more than hundreds of gigabytes? Now, I want you to be mindful, like we did that one, and I don't remember which data set it was, but it was like almost a gigabyte in size, which is like 1,024 megabytes, right? And when you think about like a typical Word document is 30 or 40 kilobytes, and then you think about how many pieces of text are in a file that's a gigabyte or a megabyte. It's like, oh my God, they're huge, right? And then we look at the little chart here, right? Like if you have 1,000,000 gigabytes, that's a terabyte, right? And some of us have hard drives that big. But what if you have 1,024 terabytes? Well, that's a petabyte. And here's the thing, right? If you look at some of those, like how much data do we produce we produce so much data. These scales are going off the charts, right? And the problem is once we get past a terabyte or two of storage, right, most of our local little machines here run out of space. So then we're looking at hard drives, and then we start filling those up. And I don't know if you guys have ever done that stuff. Like if you like download movies and games, you fill them up really quick. And if you're just downloading text files, you can go for years. Not a big deal. But when we have text files and they're filling up that much space, we're dealing with vast amounts of information. And then we got to start looking at the cloud for storing this stuff. It's really our only option. So kind of keeping on going through this, right? Another structured data format that we use quite a bit is relational database management systems. That's this acronym here. So for those of you that are either actively taking the database class, or really in principle, you should have had that quite a while ago. We know what a database structure is. A database is a collection of tables or tabular data, not just one singular table, but usually multiple tables that are linked together. In other words, the tables have relationships in between them that allow the information in the different tables to connect. And here's kind of an example of what we call an entity relationship diagram, which shows basically little tables that show the column headers for all the tables in this database, and more importantly, how they connect. So like the user ID in the users table connects to the ratings table user ID, so I know which user made that comment, that kind of thing. So you guys should remember this from your database class. My goal is not to teach a database this year, but just kind of like a refresher, right? So a database can contain a lot of different tabular data tables, and those are typically linked together, right? And those links are called relationships. Therefore, we call them relational databases, right? relational databases are really important. And let's consider this scenario here that it says, imagine instead of one small record per day, you decide to record every question asked on Stack Overflow. Furthermore, you also collect all the answers. You could store all the answers in a CSV file. However, there'd be so much data to read through the whole thing into memory, you'd have to scan through an entire file whenever you'd want to find an answer. So the concept is, that's great. You went through this website, you took the question, and then you took all the possible answers and you put them into a table, and you did that for every question that was ever asked on your website. And let's say a billion questions have been asked, and then every time you want to find the answer to one question, you got to search all that information because it's all in one file, right? Not very efficient, right? And this is where they say the database management system will assist you. It says you use it when you have a lot of data that needs to be accessed quickly. And why does it help you? Well, it helps you because it handles the search, right? So this is the whole concept of, like, you go into a database and you can write a query, and the query does the work of looking. Where if I'm in a CSV file, I just have to look at the file. Now, granted, when you're smart, you realize that Excel or even a plain text editor has a search thing. So if you're looking for a certain word, you could search for that word. But what if that word appears also 10,000 times, right? Still not very efficient. So like, even if you're using like a find feature, it might not give you what you want. In a database, though, because the data is already structured and broken into different tables, you can find the information much more quickly and narrow it down because it is already structured. That's kind of the whole thing. Databases are easy to update information. As it says here, they're very, very reliable. It's a type of data structure that's been around a very, very long time. And that the fact that the data is structured, in other words, we have data types for the stuff in there. So like if I look at let's say an age column, I know it's going to be a number. It's not going to be somebody typed a silly word in there, right? So we know the data usually is good, it's accurate, it's consistent because of the data types and the way it's structured, right? So very, very common way to store information. And databases, depending on which ones you use, can store vast amounts of information. And you can also link those databases together and have multiple databases kind of acting as one, and then you get into the data warehouse and data mining and stuff, basically. All right, so that was kind of a look at structured data. Let's start looking now at unstructured data, because that's important too. And it says unstructured data is information that is not organized in a predefined manner. Fascinating statistic. It says 80 to 90% of data generated and collected by organizations is unstructured. And I start to think to myself, is that kind of true for Gateway? Sure. In many ways, that's very true. So, sure, we have databases where you can go in and you can type in your student login or whatever, and you can see what courses you're registered for. And that's in a database for sure, right? And it's just being pulled back up on the screen. That's highly structured information and easy to retrieve. But think about all the data that like I generate for class. Like even this video I'm recording right now, I'm going to end up storing it like on my Google Drive in a folder, in my folders, blah, blah, like, etc. And Gateway has no clue, right? Like they don't know where I put my videos or where John puts their videos or Christian or Christopher put their video. You know what I mean? It's not in a logical, necessary, organized place. It is for me, right? I know where to find my stuff, but others might not do it that way. So it is basically unstructured. And on top of it, right, like if I record this on Zoom and Zoom outputs it, it'll just say video recorded on September 10th at 3:00. And that's how it labels it. It doesn't say like NLP Unit 2 lecture on it, right? Totally unstructured, unlabeled. Right. So yeah, I think it's totally true, right? Most data that's generated, people don't structure. In fact, I always hammer people about file management, especially when you start in IT programs, like know where you're putting your stuff, organize it, make folders, label them logically, name things what they are so that you can look at it later and go, oh yeah, that thing, right? Instead of going, I don't remember what I named it. Oh, it says homework here. That might be it. And then you look at 5,000 files named homework. Yeah, it doesn't work. So structuring unstructured information, big time thing. And then you think about how we all work. Yeah. Thing. All right. The thing they say here is text and multimedia are two common types of unstructured content. All right. True. Okay. So look, for example, first at this email, and I was talking about this before, where the text of an email is kind of unstructured. I don't know what the person's going to type. I don't know if they're going to spell correctly or use complete sentences or use weird acronyms or do a LOL in there or a WTF for that matter, right? We just don't know, right? And that information is unstructured and highly unpredictable. However, the outside structure of the email is structured. So, like we talked about this, the date, the two from addresses, the CC, the BCC, the subject line, all that kind of stuff. That's structured. The part that's not structured is the text inside the email window. Right. So to kind of break it down more, right? Like if you got a piece of raw text like this actually contains a lot of information. It says Marie Curie was born on the date. She was Polish, naturalized French, physicist, chemist, pioneered, blah, blah, blah. Right. A lot of information there, but it's not structured. It's just in a raw format. Yes, I can listen to it, read it, extract the information, and organize it in my brain. I'm like, oh yeah, that Marie, she was a physicist, right? So I'm attributing those pieces of information. But notice that I can take that information. This is kind of a breakdown of how large language models work. They look at a piece of text like this, and you notice there's not even like good punctuation here. And they go, oh, well, Marie Curie, apparently the subject. They've got a date of birth. Where were they born? And you notice how they're kind of breaking it down into pieces of information. So we take this raw, unstructured data and we can process it to make it structured. And then instead of it being raw information, right, or raw, I would actually call it raw data, right? It doesn't really become information until it's structured. So I think that's really kind of a nice little analogy. So examples of unstructured data. Email message fields, meaning the text inside of an email, unstructured, right? Text files, like you look inside a word processing document, a lot of times people type stuff into spreadsheets and not really label it well. You make a PowerPoint, whatever, or the log file output from your server, whatever, those are unstructured. Social media and lots of websites where there's interactivity, people that post stuff or react to stuff or comment on things or whatever, kind of unstructured also, right? I can't predict how somebody's going to comment, right? Or what reaction they're going to have. I mean, granted, parts of it are structured, but generally like a post on a social media website, unstructured information. When we text, right? We do mobile, like texting, video software, like, when we use Zoom or whatever, we're chatting or, doing instant messaging or whatever, also unstructured. Who's to know what's going to happen? It's kind of a free for all, right? You can organize it after the fact, but as it's happening, unstructured. And then we have all the media files, right? Images, audio, video, animations, etc. All unstructured information. Right. Thing is, though, unstructured information actually contains a lot of valuable information, right? And we saw that in that raw text before, right? And that raw information can lead to really important things that we can use to do valuable work, including decision making. So it says here, it can't be stored in a relational database management system because, for example, if I looked at social media posts, sometimes people just make a post and it's just a picture, they don't type any words. Or they'll share a link, okay? Or maybe they'll share a video. Or maybe they'll type a bunch of words and share an image. You see where I'm going with that, right? Like you don't know what's going to be in it. So I can't really put it in a database because I can't really like break that content down and store it. And plus, like if you send me an image or a video, it's probably on somebody else's server and I can't like download it and necessarily grab it and put it in my database, nor probably would I want to, right? Because it's inefficient storage. Somebody else is storing it. Why should I, right? It costs money. So we can't put it in a database. And because there's so many different things to store, different formats, right? And you can see all the different things that they're just pointing out here. And there's many, many more, right, that are unstructured. it, well, how do we do that? We can't structure the unstructurable, right? But it's still valuable. That's the point, right? It still contains information. It's still useful, and we have to deal with that aspect of it. So there is, or I should say, there are ways to store unstructured data, and that's basically using this, we'll call it relatively new concept of unstructured non-relational databases. This is the thing, right? This general category of database is called a NoSQL database, meaning that they kind of have rows and columns, but not necessarily, right? And so they're showing you here, for example, like if I had a relational database and I might have one table that lists posts in, let's say, on a website, and there's an ID number and a title, and then there's a comment related to the post that ID number here relates to that, and it's kind of, we can kind of structure it and tie them together. In a non-relational database, I might do it like this. So post number 2 has a title, right? And then I put an image in there. Okay, this is kind of what I'm talking about, right? And then I have post number 1 where maybe I just had a title and I just typed a couple of words and this person commented and another person commented. But you see in the non-relational, the comments travel with the post, where in a relational one, it would be in a separate table, right? And so because the comments travel with, I don't need to repeat these two pieces of information. So the tabular format in essence gets broken, but these are still attributed to that post, right? So you don't have to mire your head in this, but there are basically what we call non-relational databases that don't really work on tables, right? We think of them in a table format like this, just to keep it straight in our heads, but that's not at all how they store the information. They use different mechanisms to do it. And those are called NoSQL databases. And the combination of that kind of a free-form structure in combination with the fact that the storage costs for storing stuff in the cloud have dramatically decreased, right? Like if you go out and buy a hard drive now, you can get a whole lot more hard drive today than you could 20 years ago. And that's why it's cheaper, right? And it's true for data centers as much as our home usage. And the fact that NoSQL databases also store the information more efficiently in some ways, very, very popular for storing unstructured data. All right. So they have this group activity here, and I just want to point out that the file that they're referring to, I have placed into the course shell. So I'm just going to flip back over here to the course shell. I think we're right here. There we are. And you'll see right here somewhere. I know I included it, so I'm just going to do a refresh. Maybe it didn't refresh on this tab. There it is, the iris JSON file. And here's what's important about this. We were talking earlier about CSV files, right? The comma separated value files and how they're basically Excel files with text and commas and whatever. There's another format called JSON. And you'll notice here in the description, I asked you to download and examine the file, and it says you can use any text editor. So if you want to just open it with Notepad, that's fine. Or most IDEs will open it too. Visual Studio Code, for example, will open the file. And it says, this is mentioned in the PowerPoint, it's in the form of what we call JSON, which is an acronym that stands for JavaScript Object Notation. And this is where you're going to refresh some of your Python skills, folks. We have a data format in Python that stores information the same way. A JSON file will store the information, what we call a key value pair. And basically the description of the information travels with the information itself for every piece of information. For whatever reason, this structure has become super popular in modern programming, especially on websites that send serialized information. That means information in a stream over the internet. And this relates once again to the Python data structure called dictionaries with key value pairs. Let's take a look at the file really quick. I'm going to go ahead and download it. I know I already have it here on the system somewhere, but this just seems a little faster right now. It is in my downloads folder, and I'm just going to right click, and you can open it with any program that opens text files, frankly. I'm going to go ahead and open it with Visual Studio Code, and it might ask me to install extensions and stuff, but I just really want to look at the file. And what you'll notice here is as I zoom in, and I'm going to try to zoom in. All right, there we go. That the way the data is structured inside of here is as follows. There's an outer pair of square brackets, right? So way at the bottom of the file somewhere, there's the closing square bracket. Then I have what typically would be a row of information in a table. That's inside a set of curly brackets. So this is where it starts to look like a dictionary in Python, by the way. So inside the curly brackets, I have key value pairs. And you notice how they're so the first part here where it says sepal length, this is kind of like the column name, right? And that's text, so there's quotes around it. Then there's a colon right here that then is followed by a number, which is the data. So the number doesn't have quotes because we want it numeric. So the column header is text and the data is numeric. And then we have another piece of information or a different column, right? Separated by a comma. So these individual pieces here, that's like a column, a column, a column, right? And then each has its own piece of information. And then after that set of curly bracket key value pairs, like key, value, key, value, key, value, etc. Then that's separated with a comma and another dictionary is here. So like if you think of it from the Python standpoint, this is a list of dictionaries, right? Is really kind of a good way to put it. But the basic structure is the curly brackets, the key value pairs separated by commas, and then if I have multiple structures like that, I just keep repeating it. And this is the data set. What they've done is a very nice job in the text file here is organizing it so it looks like rows and columns, but sometimes it doesn't. You know, just giving you that heads up. Sometimes it looks a lot more chaotic, but it's still a key value pair setup, right? So that's the task there, is to look at that data file and understand that this is JSON. And JSON, for whatever reason, has become, you know, and I think mostly of web developers, because that's my primary thing, right? Is that's the number one format for transmitting data. So we go to like some website and output some data and they send you a JSON file. And then you feed that into your application and you can build a web page out of it, right? Because it contains all the information. There's a value to that format, mind you, right? Because every time you get a piece of information and you can think of the numbers or the values is really, that's the information in the table. But the definition or what it is always travels with it. So that's one reason why people like it. So I don't need to get like a data dictionary of my database to explain what the column that is, what data format it is, or why it's there, right? I just tell me the key, tell me the value, and let's move on, right? So all the info is there. All right. So now we're getting to the point where we're going to start looking at like, all right, so what are our options for actually storing information? And there's many of them, right? But what we discover is when we're working locally on our own machines and we work with incredibly large data sets, we become inhibited very, very quickly. Unless you have your own servers available, yeah, even more of a problem, right? So what most people do is they start to use cloud storage. And you know what, let's face it, all of us do this already. If you own a Windows machine or a Macintosh or a smartphone, or Android or Apple, whatever, all of them come with free cloud accounts. So if you're on a Mac, all your documents and desktop like automatically sync to iCloud by default. If you're on a Windows machine, everything in your desktop documents folder, I think downloads too, whatever, those all sync to your OneDrive if you allow Windows to do that, and that's the default these days. And if you're on your smartphone, right, those come with cloud storage too, right? And here at Gateway, we use Google Drive, right? And so a lot of us use these different cloud services. I happen to use several of them. I use Google Drive mostly for school stuff. I have a personal one too. I use Dropbox. A lot of creative professionals use this one. That one's not entirely free. I also use iCloud and OneDrive and Box and Mega. By the way, I do not use Amazon. I have used SugarSync. I don't currently in Codebase India. I've never tried or heard of, but these are just a smattering of the ones that are out there. There are many, many, many more, right? So the intelligent thing really, and why people want you to do this is like, why does Windows automatically sync to OneDrive? Well, I gave this analogy in class the other day. If I'm doing work on my computer and I save something in my documents folder and somebody comes up and takes the laptops and runs, well, it's on my OneDrive. I can still get to it. So I can just buy a different computer, log in, and get to my file. Right. See the advantage there. So all the important files you're working on, right, are out in the cloud. You will never lose them. Right. That in principle, at least. Now, some people aren't comfortable with that, granted. But I tell my students that when you're working academically or professionally, you have to adapt to that scenario because all your work files, if they went away, then what happens to you? Right? You're just done, right? So actively putting stuff in the cloud really makes a lot of sense. They start to talk here and they have this example, and I feel like I should explain it a little bit. Like if you store stuff in the cloud, how does it sort of work? Right? So you're sitting here on your local computer connecting through the internet, and you connect to your website, right? And what Nginx is wondering, that's web server software. So this is what runs the website. So you hit the web server sends you a page back to your screen, maybe with a listing of files, right? And then you click on one of those files and it goes back to the web server, and then that connects you to the actual storage, right? Wherever that is on a server somewhere, right? Then it retrieves the file to the web server, and the web server pushes it back to your computer screen, right? So that's kind of the mechanics of it, but the point is you access your stuff through the cloud. Now, what I always show students here, and I usually lecture on this too, is like, I actually know that with most of our cloud storage services, OneDrive, Google Drive, Dropbox, those are probably the primary three, or iCloud that people use regularly and automatically. A lot of people don't even know they're using them. But with Google Drive, for example, you don't have to use Google Drive through your browser alone. You can go to Google and search for Google Drive file stream, and it is an installable piece of software that runs resident in your system tray, like you see here on my system. And then in my file explorer, my Google Drive comes up as Drive G. It comes up as a drive letter. And then everything that's here on my drive is not actually on my computer. It's out on the cloud, but it looks like it's on my computer, and I can interact with it as if it's on my computer. And really kind of the tip that it's in the cloud. I don't know if you can see the little icon there. It's like a folder with the cloud on it. And then if I update a file, it shows a little sync window. So until it syncs, it has a little wheel on it, and then it turns back to a cloud. But this is a great way to work, folks, because all the work I do here professionally at Gateway, all my stuff goes in here, right? And that way, if somebody steals my computer, oh well, they got the computer, they don't have my files, and that's really what's valuable, right? Information is valuable more than the machine. Right. Commonly used cloud storage services. We got to talk about AWS, because AWS is, I think I've told you guys this before, the primary business activity of Amazon. People think it's selling you product. Nope. Amazon overbuilt their infrastructure, has huge server farms, and most big platforms that need a big stable cloud environment to operate upon. The one I always use is Netflix as an example. They operate on top of Amazon Web Services. So Amazon is bigger in selling their web services and cloud storage and server platforms than they are in retail. And that blows my mind always. But AWS is the big one, right? And that's their cloud storage. Google has a cloud storage platform also called Google Cloud Storage. Microsoft has one also called Microsoft Azure, right? Very big, popular one. And really probably the two most popular are AWS, followed by Azure. And maybe, I shouldn't say that with any certainty. Maybe Google's bigger than Azure is, but those are the kind of like the big three for cloud storage. And I'm not just talking about for you and me putting our couple of files out there. I'm talking about big, giant enterprises that run their applications and servers off of the platform. That's what we're talking about here. And when we're doing large language models, you need huge data stores, and they've got to be scalable too. So this is the other reason why people go to the cloud, is because I can get a certain amount of space, let's say from Amazon or Microsoft or Google, and I'm like, oh, I filled it. Well, I can just ask them for more, pay a little bit more money, and they give me more space, right? And that's one of the advantages to that. It's not like you fill the hard drive and that's it. You just say, okay, I need more, and they give it to you, right? Here's kind of another thing that's kind of happening. So like we are moving into this era now that we went into these like NoSQL databases, but vector databases are a thing on the rise. And I think before I didn't know how to really define it myself. So I did a really quick search on what is a vector database. So here's what Google's AI search returned. It says a vector database stores and receives data by indexing it as high dimensional numerical vectors or embeddings, which represent the semantic meaning of the data, like text, images, or audio. So instead of it being in rows and columns, being tabular data, it's stored in vectors. And remember, we talked about that. Vectors are kind of basically little mathematical formulas or values. And they really focus on the high dimensional data. So if there's like many features to a data set, and then kind of the interconnections or the meanings of those pieces of data, and the connections are through the meanings, right? And so now when you start to think about large language models and what those are supposed to do, or process natural language, it's all about meaning, right? So this database structure becomes really ideal for doing large language models, because they're kind of built in a way that language is built. It's kind of a way to think about it. And it says they're popular for storing LLM data because they can scale across compute and storage, or different storage and computers options, so they can link them together and provide a form of persistence to query and retrieve domain-specific information by performing what we call similarity search. Oh, like this is similar to this, and that's kind of how those databases work. Now, when we look at like vector databases, right? So we have like these regular cloud storage providers like Amazon and Microsoft and Google, right? Where you just, oh, here's some storage online. You can take your traditional files and put them out on this traditional storage platform. But these companies here are database providers that provide vector databases online, and a lot of large language models are stored on here because they're kind of designed to do it, right? So, and these are names you probably have never heard of unless you're working in the field of doing large language models, right? But these are systems and database providers for doing vector databases. They say, like, when you're choosing one of these providers, that you have some things to consider, like, is it scalable? Does it do vector? Does it do the similarity calculation? Can you manage the data? Does it have failover? And is it secure, right? I mean, those are pretty standard considerations all the way around. But the vector operations and the similarity calculations, these two things, right, are what make it kind of unique. So you want to make sure that those are present, and generally they are. They have a bunch of different advantages over regular relational databases. So some key features to consider when comparing them: cost effective, they process faster, they're scalable, right? Regular databases are too. Precise similarity matching, so much better at coming up with things that are similar than what you would do in a search in a database, which will look for exact, pretty much. The search capabilities are far more advanced, and there's also real-time analytics built into it, which are really great features. All right. So it says, overall, vector databases offer a cost-effective and efficient solution for storing and retrieving vector data, making them an attractive option for LLMs. Remember, LLMs are built upon machine learning algorithms and deep learning algorithms, which are built upon vectors, right? So you can see where that's going, right? And why it makes sense. And so not only is it good for LLMs, it's good for a lot of AI applications that require a lot of vector processing, basically, is the point. All right. All right. So this is a group activity. Obviously, I'm recording a video here, so we're not doing it as a group or anything like that. But let's kind of do a quick recap of the data types and then talk about it. And basically, here's the first question. Is this structured or unstructured data? All right. So clearly it's structured. If you guys remember, we were just talking about JSON files. These are key value pairs. So a key, right, image, and the value, right? Key, value, comma separated, curly brackets wrapped around it, and then next set of data separated by a comma, right? On the outward edges of it, square brackets to hold it all in. Python dictionaries or JSON files, right? So this would be a JSON file, but very much structured, absolutely structured. Is this structured or unstructured data? Once again, rows and columns. Columns are named, data is organized, same data types, whatever. This is clearly structured as well. Is this structured or unstructured? But this is just a snippet of text. Does it contain information? Yes, but it's not structured information. I could process it and make it structured, but currently as it sits, unstructured. If I were to throw an image on the screen right now, unstructured. A video, unstructured. Right. So I think you get the idea of like what's structured or unstructured, and that's kind of helpful. We are done for the day, so this concludes the lecture portion. They do have some reflection questions here, which might be interesting ones to look up. And if you want, and this is kind of a thing and not required, not bad ones to drop into a Gen AI and ask it these questions, right? So it says, how do companies such as Google, Amazon, Spotify, and all these acquire data? Well, they don't have to do much because you're like, think about this. If you're on Instagram, well, people are posting data, so they don't have to acquire anything. You're putting it in there for them, right? How does Netflix acquire information? Well, they look to see, what did you click on? What did you watch? Did you give it a thumbs up or a thumbs down? That type of thing, right? So that's where they're getting their data. And then as a business owner, would you prefer structured or unstructured data to understand your target audience? I think most business owners very, very quickly would say, I want it structured so I can understand what I'm looking at, right? But we can take unstructured data and put it into structured formats. In other words, process it to make it structured, and extract information from it. So I think generally a business owner would say structured, right? Is there value in unstructured? Absolutely. That's kind of the point of all of this. All right, folks, this concludes the lecture. Just putting up the bibliography here for anybody that wants to extract it. There's a lot of reference links here, quite a rich set of them. I don't know how many of these links still work, but I'm clicking through all of them for the sake of the video. And this video ends here.